Okay, we're back. This is Techmath2. We are looking at the midterm review. Now, just so you know, in your packet, it just says College Techmath2 Final Exam Review. So the midterm is the first 3 pages and then just the top of the 4th page, just up to chapter 10. And then the rest of it is the second part of the final that'll happen in May. Now, I put all of it on the blank one. I posted all of it because of the answers. So the answer key is the last page, 7 and 8. And so that's why I did the whole thing. But I put a little note on it where I put it in Blackboard that it's just the first 4 pages. So that's what I was talking about with just the first 4 pages. Okay? Okay, so let's jump into it here. It's back to chapter 1 and 2, so all of this should be reviewed. We've done all of this already. You've already been tested on all of this. You've already done all the homework on all of this. So upside and downside, on the upside, there's no homework really that goes with this, just the review. That's the only thing you're going to send me this next weekend. And hopefully you remember most of it. So let's take a look. Using the unit circle defines sine. So they want the sine. Remember what sine is. It is opposite over hypotenuse. That's what that little SOHCAHTOA means. So opposite over hypotenuse. So sine theta is equal to y over 1. Or just plain old y. So sine theta equals y. And that's what they're going to have on the key. All right, in which quadrants are sine and tangent both negative? So this is where all-star trig class comes in. All-star trig class. That's a mnemonic device to remember that all 3 are positive in the first quadrant. So the first quadrant is out. They want to know where tangent and sine are negative. All right, sine is positive in the second, so that's not going to cut it. Tangent is positive in the third, so that's not going to cut it. So this one's out, this one's out, and this one's out, because those are positive. So it is the 4th quadrant that both sine and tangent are negative. All right? Lovely, lovely. Let's take a look. So that was 1 and 2. All right, and I don't think there was no work for those, so I didn't really put that down. Doggone it, I just had a little minor crap-a-lanch back there. So that was 1 and 2. On the key, I started with 3, 4, and so on. And so let's take a look. 3, 4, 5, 3. What angle between 0 and 360 has the same terminal side as negative 750. So this is, again, you're going back and you're going around the wrong way. So negative 360, negative 720, and then another 30 degrees past that, right? So that would be the same as now, so negative 30 degrees, right? Because we went clockwise 360 and then 720 and then 30 more to get to negative 750. So it stops right there. It is coterminal with, if you go positive around this way, that's positive 330. You could also take negative 30 plus 360 to get positive 330. So there's 2 different ways to do that. Let's look at number 4. Express 240 as radians in terms of pi. Okay, so 240 as radians with pi in your answer. So what is that going to look like? (240 degrees). That is pi 180 degrees. Remember, pi radians is equivalent to 180 degrees. So I'm essentially multiplying it by 1. These degrees cancel, so I have 240 pi over 180. And then they want it in terms of pi, so I'll just reduce that down. The zeros cancel, and then what? I can divide by 6 and get 4 pi over 3. Okay, lovely. Okay, let's take a look. Convert 3 pi. Oh, I made one up. Because in the review they have a degrees one, and so I made one up that's 4.5. I wrote a little made up. So 4.5, look. What if I have to convert 3 pi over 10 radians back to degrees? If I want to go back to degrees, because there's one like that on the test. But there wasn't one like that on the review. So that's why you have little add-ons on my key. And so if you were wondering why did he make up 4.5, that's why I made up 4.5. So so what would that look like? That would be 3 pi over 10, and that's radians. And so I would multiply by 180 degrees over pi radians, and the radians would cancel, and the pi's would cancel. And so I'd have 3 times 180, that's 540 degrees over 10, and now I reduce that, and so it reduces to 54 degrees. So there is one like that on the midterm, but it wasn't on the review, so that's why I tossed that one in there for you. I got your backs. All right, let's take a look at chapter 2. Okay, so chapter 2 has number 1, the length of the resultant vector. Oh, so these are kind of tough. So 2 vectors of 310 units, 190 units act on an angle of 54 degrees. So this looks like this. So one of them you just put on the bottom here. We'll call that one the 310. And then the other one we're going to do at 190 at 54 degrees. So somewhere in this neighborhood, 54 degrees right there. And this is 190, although it probably wouldn't be that long. Probably like that, okay? So now remember how we do this. We have to find the resultant vector. So that is, you make a parallelogram, and then the resultant vector happens like this. So remember, we have to put this into rectangular form. So that is 310, comma 0. This we also have to put into rectangular form, and so that's the tricky part, right? So we're going to bust out our calculators, and we're going to go from polar to rectangular x, all right? And we're going to do 190, comma 54. So we just did this. We just did this in chapter 10, but it was with imaginary numbers instead of real numbers. So we're back in the real number section. So here, let me show you what that looks like. We bust out our calculator, we go second apse, that's angle. We go down, polar to rectangular x, hit enter. And now we do 190, comma 54, n paren. Okay, so it's that, and then you hit enter. And we got 111.679. Okay, polar to rectangular y, 190, comma 54. And you find y. You could also find y by taking 190 times the sine of 54. You could also find x by taking 190 times the cosine of 54. Make sure you're in degrees. But so you hit that, you tick that in, And so what does that look like? That's 153.713. All right. So now we have this point, 111.679, comma 153.713. Okay, so not very pretty. And then remember what we do. We add them up. So we take that 111.679, comma 153.713 and add it to 310, comma 0. And that will give us this resultant vector. So our resultant in rectangular form is, what does that work out to be? 421.679, comma 153.713. And now, do they want, we've got to convert it back into polar form. So they want this resultant vector. We have the answer in rectangular form, but they want it in polar form. So here, let's simplify it. Let's make it 422, comma 154. We can simplify it at this point. And now we want to go back. So that is from rectangular to polar r, 422, comma 154, and rectangular to polar theta, 422, comma 154. And so r is equal to, you tick that into your calculator again, that second angle. We go down, down, down until you see rectangular r to polar. Hit enter, 422, comma 154. And that's 449.22, so we'll call it 449 units. And theta, you could do the arctangent if you wanted of 154 over 422. You could also use Pythagorean's theorem, do 422 squared plus 154 squared, add them together and take the square root. That would give you the 449. And so from polar back to rectangular, and we end up with 20.048 or 20 degrees. So our final answer is they want to know A, what is the units that it goes out at, and B, the angle between. So the resultant vector OR is 449 units, that's part A. And then part B, they want to know the angle, that's 20 degrees. All right? Okay, let's do, oh, do they do one like number 2? I did not do number 2 on the key because there isn't one like number 2 on the test, all right, where you have to use the component method. So that's why I crossed that off. So that's why I skipped that one. If we were in a face-to-face class, I likely wouldn't cover number 2 unless there was a specific question about it, because there isn't one like that on the test. All right, so let's continue on to chapter 6. Okay. So that's why number 2 isn't worked out all the way here. I wanted you guys just to focus on the ones that are going to be on the test. That's why on the key thing, I kind of I highlighted the ones in purple that you should focus on for that, for the midterm, all right? Because it's coming up on us pretty quick, so I was trying to give you a little bit of a heads up so you weren't over preparing, all right? So let's look at chapter 6. It looks like 1, 2, 3, and 4 are all marked. So there's one like each one of those on the test. So let's look at chapter 6. We got 1, 3d squared, p to the negative 3 over 6d squared, p to the negative 4. So remember what We reduce the 3/6 like how you reduce all fractions. Divide by 3, divide by 3. So that is 1 over 2. D squared on top, D squared on bottom. So those all are gone. P to the negative 4 goes up on top. E to the negative 3 goes down on bottom. But now I still have to reduce those. So 4 on top, 3 on bottom. They cancel 1 for 1. 1 left on top. P over 2 is the answer for that problem. Okie dokie. Let's take a look at number 2. They want us to write it as a decimal exponent. Now, if I recall, some of you messed this one up when this was on test 6. So don't make that same mistake. Remember, what's inside, that goes on top. What's outside the carriage, that goes on the bottom. But we're not done. We have to take 3 divided by 5 on our calculator and get 0.6. They want it as a decimal exponent. So p to the 0.6 power. All right, number 3. We're going to do multiply 7xy squared times the square root of 14x cubed y cubed. So you multiply that out and you get 98x to the 4th y to the 5th. Now, you want to separate perfects and leftovers. Perfects and leftovers. So what we're going to do there is separate it out into 49x to the 4th, y to the 4th. I said 4, but I wrote 5. Okay, and then leftovers. Well, 49 times 2 is 98. X4, we've got them all taken care of. Y5, so there's Y4 there, so there's a Y in the leftover bin also. Now, after you get it perfects and leftovers, you can now execute this square root. And so 7 is out, x squared is out, y squared is out, and square root of 2y is stuck. Okay? That's one way to do it. Another way to do it would be to break it down into its prime factorizations, what I refer to as like the prison break method. So 14 is 2 times 7 times 7. We got 1, 2, 3, 4 x's. We got 1, 2, 3, 4, 5 y's. And now you're looking for groups of 2. Groups of 2 escape. Okay? So we have a group of 2, but only 1 lives. So a 7 is out. Group of 2 x's, but only 1 lives. Group of 2 x's, but only 1 lives. Group of 2 y's, only 1 lives. Group of 2 y's, only 1 lives. Stuck and stuck. Square root of 2y, and now multiply. So 7x squared, y squared, square roots of 2y. Okay? Either way, you'll notice we get the exact same answer. So whichever way you prefer to do it, I'm fine with either way. Now, with number 4, it looks complicated, but it's probably the easiest one on this section in chapter 6. You just have to plug and chunk. So that is just a calculator problem. And there is one like that on the midterm, okay? So number 4, we have Q is equal to W over R to the A power. So when we have a power raised to a power, we multiply, but you don't even have to worry about that because they give you 450 and 130 and 0.4. And so you just literally click that in your calculator. Make sure you use parentheses and the little power, right? So it would look like this on your calculator. And parentheses, the little caret, and then 0.4. And then you hit enter. And around 100ths, so that's 1.64. Okay? Excellent. So that is chapter 6. We'll plow on to chapter 7. I'm going to make another video. This is part 1.